Training Module 4, the assessment criteria of the contextualized SESBA MET SB tool carried out on a building scale. So in this presentation we are going to consider the energy from renewable energy sources in the total electric energy consumption. This indicator falls under the issue of energy and resource consumption, and it's under the category total life cycle non-renewable energy. It is an indicator which evaluates the progress towards the Renewable Energy Directive of 2009, and it gives a measure of how much progress is being done towards the targets. In this slide we can see that renewable energy constitutes 3% in the services sector, while it is 16% in the residential sector. The slide shows the percentage renewables for different countries in the EU. Renewable energy sources includes hydroelectric, wind, biofuels, as well as solar sources. So the objective of this indicator is to maximize the use of renewable energy sources. It could be photovoltaics, wind turbines. As already mentioned, this indicator helps in order to assess the progress of the targets for 2020 and 2030. This indicator is computed as a percentage of the total electricity demand. So basically it is the electricity demand derived from the renewable part divided by the total electricity consumption per year. During the design stage, the indicator is computing using an estimation, while during occupancy stage, actual metering data will be used. The scope of this indicator should include electricity used for heating, cooling, ventilation, domestic and hot water, lighting, as well as auxiliary devices. These are the standards which are relevant to the computation of this indicator. It is possible, as already mentioned, to use both metered or estimated data for the energy use. However, the source of data should be clearly declared. So the assessment method, ideally we use actual measured data, so we can have the measured data from the main grid, the actual measured data from the PV panels, from the renewable sources, from which we can compute the ratio. We should at least have 12 months of consecutive data in order to remove any seasonal fluctuations. Ideally, a 3-year average is carried out in order to remove any long-term variations. The use of BEMS and BMS systems may be useful because we can remove any energy usage which should not be in the scope of this indicator. For example, we should not include any plug loads or any cooking in the energy usage. So desegregation can be carried out using BEMS and BMS systems. Here is an example of the average annual average output for Greece and other big cities. So at the design stage we can calculate the energy produced and used on site from renewable energy sources. We also know the total amount of energy used which will be used from the grid, from which we can compute the ratio. This indicator can be evaluated at the design stage, and it's evaluated from the estimated electrical energy from the renewable sources divided by the total electrical energy for the building and expressed as a percentage. For existing buildings, ideally we have actual meter data, which should be at least for 12 months. It is better if we have 3-year data in order to perform an average. So basically we measure the actual values in this case from the main grid and from the renewables. We perform the averaging and then we compute the ratio. The indicator can also be evaluated at the occupancy stage using actual electricity measured from the renewable energy sources, as expressed as a percentage of the total measured electrical energy for the building. The slide shows the relevant standards for this indicator.